देखिए अगर आप कुछ कॉपी नहीं कर पा रहे तो कोई दिक्कत नहीं है, आप तो नोट में भेज देता हूं, तो इसलिए उसमें कोई प्रॉब्लम नहीं होगा। Okay, this question. An open lift is moving upward with velocity 10 meter per second. It has an upward acceleration of 2 meter per second square. A ball is projected upward with velocity 20 meter per second relative to ground. Find time when ball meets the lift, displacement of the lift and the ball at that instance, distance traveled by ball up to that instance. Okay, so first we will make the diagram. So an open lift. So this is the lift. Lift is like this. This is the lift. An open lift is moving upward with speed 10 meter per second. It has an upward acceleration of 2 meter per second square. So this is also accelerating. Accelerating upward with 2 meter per second square. A ball is projected upward with velocity 20 meter per second relative to ground. Relative to ground. Okay, 20 meter per second relative to ground means the ball is projected upward. The ball is projected at speed 20 meter per second. 20 meter per second with respect to ground. Time when ball again meets the lift. Time when ball again meets the lift. So for this, you can see that if you consider, since the lift itself is moving, the ball is also moving. We should consider the relative motion. We should consider the relative motion. If you consider relative motion, then with respect to lift, we have to consider the motion of the ball. So relative to lift, we will solve everything with respect to lift. So with respect to lift, what is the relative motion, relative velocity of ball? So relative initial velocity of ball. So ball with respect to lift. Okay, UBL. So ball with respect to lift. So that is 20 given minus 10. Lift itself is moving with 10 meter per second. So that we are getting how much? 10 meter per second. With respect to ground, the velocity of projection is given with respect to ground. So that we are subtracting from the lift velocity, we are getting relative velocity with respect to lift. Now it is thrown upward and time when the ball again meets the lift. So what we are going to do is what will be relative acceleration now? Relative acceleration. So relative acceleration of ball with respect to lift. So ball is going downward with 10 meter per second square and lift is going upward. So that has to be subtracted. I am writing one more step. So acceleration of ball minus acceleration of lift. So acceleration of ball is how much? Acceleration of ball is minus 10 meter per second square and acceleration of lift is 2 meter per second square upward. So if we subtract, we are getting minus 12 meter per second square. These are the acceleration and velocity. Now we have to find the time elapsed. So for finding time elapsed, we have to write equation y equal to all the things relative. Y equal to uyt plus half ay t square. So everything we will write relative. So y will be relative. So displacement of ball with respect to lift, relative displacement, that will be 0 because finally again ball is on the lift itself. Then u, the velocity of ball with respect to lift. Then acceleration of ball with respect to lift. Everything in relative frame. So finally the ball has to come at same point with respect to lift. So displacement is 0. How much will be initial velocity? That will be 10 times t and this is half and 12 and t square. So we can write 0 equal to 10t minus 6t square. So time is first is 0 and then 10 by 6. Okay, so these are the two times. So 0, comma 5 by 3. So this is the time. 5 by 3 second will be the answer. 0 is corresponding to the initial point of projection. 5 by 3 will be the answer. Displacement of lift and the ball at that instant. So what will be displacement of lift and the ball? So displacement of lift, if we say, that will be how much? That will be velocity of lift is given, acceleration of lift is given. So velocity of lift t plus half acceleration of lift t square. So we will put all the values. So velocity of lift was 10, time is 5 by 3, half acceleration of lift is 2 into 5 by 3 square. So this much we have to do. It will be 50 by 3, this cancelled, 25 by 9. So we have to solve this 9, and this will be 150 plus 25. So whatever we get, 175 by 9. So this much will be the displacement of lift. Now, what will be velocity of lift? So velocity, displacement of ball. Displacement of ball. What will be displacement of ball? So displacement of ball, if we say, it will be initial velocity of ball into time t plus half acceleration of ball into t square. So in this way we can write. So displacement of ball is initial velocity of ball is how much? Initial velocity of ball. So that is given 20. 20 time is 5 by 3. Then half acceleration of ball. So acceleration of ball will be equal to gravity because it is moving under gravitational influence. Once it is thrown, after it is detached from the lift, the acceleration on it is acting is minus 10. So minus 10 into 5 by 3 square. So if we solve it, we will have 100 by 3, and here it will be minus 5 and 25 by 9. If we solve it, it will be 9 here and 300, and then it will be 125. So we will have 175 by 9. So this much will be the displacement of ball. Okay, so these two are coming same. You can see we applied the formula. These two are coming same. Why these two are coming same? Because the ball is falling on the lift itself. Ball is falling on the lift itself. So they should have the same displacement. Finally, they are at the same point. So they should have same displacement. Now we have to find distance traveled by the ball up to that instant. So how do we find distance traveled? So for finding distance, what we can do is we have to check that whether ball is returning at some point or not. So first we need to check, see how distance and displacement are different. If a ball is projected upward, suppose the ball goes upward and then returns back. So if you find the displacement will be only this much. The displacement will be from A to B, suppose. And the distance will be what? From, suppose this is point C, then D, then A. So distance here is CD plus DA, while displacement is only AB. Okay, so these two may be different if the particle is returning on its path. Particle is changing the direction of velocity. As you can see, that particle is changing the direction of velocity at point D. The distance traveled and the displacement, these two are different things if the particle changes its direction of velocity. Okay, so that we need to check. So at what point the particle is changing its velocity, that we will first see. So at what point it will change its velocity, direction of velocity? At highest point. So when the particle will have zero velocity, at highest point velocity is 0. So we will see at what time the velocity is becoming 0. So we will use the formula V ball equal to U ball minus GT. So initial velocity of ball was 20 and U ball, final velocity of the ball is 20 at highest point, and initial velocity was 20, G is 10 and T. So T equal to 2 seconds. At T equal to 2 seconds, the ball is changing its direction. So how should we solve it? Now, see, t equal to 2 seconds, the ball is changing its direction. But if you see at this one, if you look at this one, this is less than 2. Means the ball is not changing its direction till it reaches the point, till it meets the lift. Okay, we are getting 5/3 here, and here we are getting what? Initial velocity of ball is 20. So we are getting at 2 seconds. At 2 seconds means after this point. Time elapsed before 10 meter per second, 20 meter per second. Okay. So we are getting the time. The time is greater than this time. So the ball is changing its direction of motion after this moment. So no need to take the extra thing. The displacement will remain same. The distance will remain same. Distance is going to remain same as displacement.